All right, calculus friends, let's keep on rocking and rolling here. This is question number 3 from the 2019 BC exam. This is the first calculator inactive question that you would have seen. Okay, so we've got a graph. This is the graph of f, okay? The continuous function f is defined on the closed interval -6 less than or equal to x less than or equal to 5. The figure above shows a portion of the graph of f consisting of 2 line segments and a quarter circle. Okay? Line segment, quarter circle. Got that. The quarter circle is centered at the point 5, 3. So there's the point 5, 3. It is known that the point 3, 3 minus the square root of 5 is on the graph of f. So this point right over here has coordinates of 3, 3 minus the square root of 5. Okay, let's see what's going on. In part A, if the integral from -6 to 5 of f of x dx is equal to 7, find the value of the integral from -6 to -2. Show the work that leads to your answer. Okay. So they're telling me that the area bounded between x equals -6 and x equals 5, the graph of f of x and the x-axis is equal to 7. Well, I can see the part of the graph from -2 to 5, but I can't see the part of the graph from, -6 to -2. So that's going to be a little bit tricky. Fortunately, they gave me some information. We know that the area from -6 to 5, the integral from -6 to 5 f of x dx is equal to 7. And they want me to find the area from -6 to -2. So my first thought is I know that with integrals, I can break this up into 2 different integrals. So consider this for a second. The integral from -6 to -2 of f of x, that's what I want to find out. When I add it to the integral from -2 to 5 of f of x dx, well, that has to be the same as this integral from -6 to 5. So adding the 2 integrals together gives me a value of 7. Using some algebraic and geometry trickery, I can figure this part out using the graph. The integral from -2 to 5 just says I have to find the area from x equals -2 all the way to x equals 5. I can figure this out, and then I can say, well, the part that I don't know added to the part that I know is equal to 7, and I can subtract. So here's what I'm going to do. The integral from -6 to -2 of f of x. I don't know what that is, but we are going to take the time to figure out the area from -2 to 5. Starting at x equals -2, I have this triangle over here. Area is going to be base times height, cut that in half. That has an area of +1/2. This part of the triangle down here has an area of -1/2. Those guys cancel each other out. Okay? So those 2 cancel each other out. This little triangle below the x-axis has a height of 1. It looks to have a base of 1/2, and it's below the x-axis, so I'm going to say 1/2 times my base times my height. Keep in mind that's all negative. That gets me that area. The next part I'm interested in going from this point here to x equals 2. Now that is another triangle. It's above the x-axis, so 1/2. The base is going to be 1.5 or 3/2. The height is 1, 2, 3. So far, so good. I've calculated that area. What's left is this region underneath the semicircle. So all of this. Unfortunately, I cannot find that area directly. I'm going to have to get a little clever with this. So what I know is that I've got this square. And if I look at the area of the square, which is going to be 9, and I knock out the area of the quarter circle, it'll give me the area that I'm after. So I'm going to start with an area of 9, and I'm going to subtract from this the area of the quarter circle, 1/4 of pi. My radius is 3, so 3 squared. All this is the area from -2 to 5. When I add this area with the area from -6 to -2, I'm going to get 7. Well, we can clean this up a little bit if we want to. The integral from -6 to -2 plus, what do we have here? 1/2 times 1/2 is 1/4 times 1. I'm going to have a -1/4. 3/2 times 3 is 9/2 times 1/2 is 9/4. That's convenient. Plus 9 minus 1/4 of pi times 3 squared is 9 pi over 4. Okay. The integral from -6 to -2 of f of x with respect to x, plus inside here, -1/4 plus 9/4, that's going to be 8/4. 8/4 is 2, plus 9 is 11, minus 9 pi over 4 is equal to 7. I want this part here, so I'm going to say then that the integral from -6 to -2 of f of x with respect to x is going to be 7 minus 11 minus 9 pi over 4. You can simplify if you want to. There's no need to. The simplified version is 9 pi over 4 minus 4. Let's look at what they did for points. This initial statement where you are replacing this one integral with these two very specific integrals gives you 1 point. Correctly determining the integral from -2 to 5, that was all of this work. Unsimplified or simplified was a second point. And then finally reaching here is your third point for a grand total of 3 points. I like that. It's a little tricky. There's some nice access points though. Simplifying is definitely not something I would encourage anybody to do. You're just running all sorts of risks and making mistakes. All right, let's keep moving. Part B. Evaluate the integral from 3 to 5 of 2 times f prime of x plus 4. The integral from 3 to 5 of 2 times f prime of x plus 4. Okay, well, I don't know that we're going to have any algebra trickery here. But what I do know is this. You want me to find the integral of 2 times f prime of x plus 4. I can use some integration properties to say that this is the same as the integral from 3 to 5 of 2 times f prime of x with respect to x, plus the integral from 3 to 5 of 4 with respect to x. I'm breaking this into two different integrals. I'm using the distributive property of integrals over addition. This 2 that I'm multiplying by is a constant that can get pulled outside. So now I have 2 times the integral from 3 to 5 of f prime of x dx plus the integral from 3 to 5 of 4. Now, you might say, well, gosh, what's going on over here? Couple of options. The integral of 4 is 4x, and you can evaluate from 3 to 5. Or you can keep in mind that y equals 4 is a horizontal line. So you're asking me to determine the area from 3 to 5 underneath the line y equals 4. Either way you do this, what you're going to do is if we do the integration, you're going to say that this is 4x, and you evaluate from 3 to 5. You plug in the 5, you get 4 times 5 minus 4 times 3, you're going to get 12, and you're going to get 8 for this little part over here. If you had looked at it as an area computation, here's the line y equals 4, here's x equals 3, here's x equals 5. I want to find the area of this rectangle. The length is 2, the height is 4, the area is 8. Works out no matter what. Let's look at this first integral though. How do I integrate f prime of x? Well, f prime is the derivative of f. I want to find the antiderivative of that. Well, the integral of f prime is just f of x. And I'm going to evaluate that from 3 to 5. Okay, we're getting a little messy here. We've got all of this plus, and that's why I think it was a really bad idea for me to do this work over on the side. I should have done that separately, sorry. Anyway, we have 2 times f of x, evaluate from 3 to 5, plus 8. So this is 2 times f of 5 minus 2 times f of 3 plus 8. F of 5, I can pick off from the graph, is 0. Plus f of 3. F of 3, the y value in x equals 3, we've determined, we were told, was this 3 minus the square root of 5. And then plus 8. I can stop here, or I could distribute and say this is 6 minus 2 square roots of 5 plus 8. I feel like I made a tiny mistake here somewhere. It was, oh, that's why. Sorry, friends. 2 times f of 5 minus 2 times f of 3. F of 5 is 0, so 2 times 0 minus 2 times f of 3. So this would be minus 6 plus 2 square roots of 5 plus 8. Simplify that, and that is going to be 2 plus 2 square roots of 5. All right, for this problem, what did the College Board do? They awarded 1 point for the fundamental theorem of calculus. That's in this step here where you recognize that the integral of f prime of x from 3 to 5 is the same as f of x being evaluated from 3 to 5. That was 1 point. And then for reaching your final answer, any of these, simplified or not, is the second point for a grand total of 2 points. Sorry, that one was a little messier than I had expected. See if I can do a better job with part C. Okay, part C, the function g is given by g of x is the integral from -2 to x of f of t dt. Find the absolute maximum value of g on the interval -2 to 5. So on the interval -2 to 5, what I want is the maximum, or the absolute maximum, value of g. Now, you guys are in a Calculus BC class. You should be comfortable with this process. And you know that in order to find the absolute maximum or the absolute minimum value of a function, the first thing we do is we look for a candidate. The candidate is going to be where g prime, if you're looking for an absolute max, you're looking for where g prime makes a change from positive to negative. That's in general what you would do. Well, how do we find g prime? G prime is the derivative of this integral from -2 to x of f of t dt. The derivative of the integral of a function from a constant to a variable. This is the second fundamental theorem of calculus. Derivative of the integral of a function from a constant to a variable is just the original function back again. So g prime is f. This is good news for us. We have the graph of f. If I want to know where g prime changes from positive to negative, I can say g prime changes positive to negative. Where does that change happen? Well, it happens over here at x equals -1. I can see that change at x equals -1. And I know that because f of x is equal to g prime changes positive to negative. That's my candidate. That doesn't mean that that is the location of the absolute max. It just tells me that's where I might have this happen. I'm also going to evaluate my endpoints. Well, the endpoints are x equals -2 and x equals 5. What we're going to have to do is we're going to have to evaluate g at -2, g at 5, and g at -1. We're going to be looking to see which of these three values is the greatest. Well, g of -2 means go to my function, and I'm going to evaluate that integral from -2 to -2, f of t dt. Well, the integral from -2 up to -2 has to be 0. To find g of 5, that's the integral from -2 to 5 of f of t dt. Well, wait a minute. The integral from -2 to 5, I think we actually did all of that work earlier. That was all the way back in part A. The integral from -2 to 5 was this computation, which was all this mess here. When we simplified it down, we got to 11 minus 9 pi over 4. There's no need to do that work again. We've done it once before, so use that result. G of 5 is 11 minus 9 pi over 4. And finally, we need to evaluate g of -1. Well, that is the integral from -2 to -1 of f of t dt. To do that, I'm going to look at my graph from -2 to -1. That's this little triangle here. The base is 1, the height is 1. The area is going to be 1/2 times the base times the height, which is 1/2. So now here's the part that's going to be a little bit tricky, is you've got 1, 2, 3 different values. Which of these is the absolute maximum value? Well, it's clearly not 0 because 1/2 is larger, but now you're going to have to go through the mental gymnastics here and kind of think about 9 pi over 4. Well, what do I know? I know that pi is a little bit bigger than 3, right? Pi is like 3.14, blah, blah, blah. A little bit bigger than 3 times 9 is what? A little bit bigger than 27. Maybe it's even bigger than 28. Divide that by 4, you're going to have some number that's maybe a little bit bigger than 7. 11 minus a number that is a little bit bigger than 7 is going to be greater than 3, which is greater than 1/2. So this must be the absolute maximum value. So the conclusion is the absolute max value of g on the interval, what's the interval that we're looking at? Where did it go? On the interval -2 to 5 is 11 minus 9 pi over 4. College Board awarded 3 points for this. First point came in with making the connection that g prime is equal to f. The second point comes in when you recognize that x equals -1 is a candidate. And then the third point comes in, they just called this answer with justification. That's all of this work that we did here. That third point is going to be a tough point to earn, but I think the first point and the second points were rather friendly ones that I would expect you guys to be highly successful with. All right, let's close out with part D. Okay, part D says find the limit as x approaches 1 of 10 to the x minus 3 times f prime of x over f of x minus arctan of x. Don't worry, this problem looks much, much worse than what it actually is. If I'm going to evaluate this limit, one of the first things I would encourage you to do always, always, always is try direct substitution. Maybe your teacher called it evaluation. You probably remember it as plug in. What happens with this function here if I evaluate it at 1? I'm going to get 10 to the first minus 3 times f prime of 1 over f of 1 minus arctan of 1. Now that may not make any sense yet, but let's keep cleaning this up. 10 to the first power is 10 minus 3 times f prime of 1. Remember, this is the graph of f. F prime means slope of the tangent line at 1. How am I going to find the slope of the tangent line? It's the same as the slope of the line that I'm on. The slope of the line, I can do rise and run. Rise 2, run 1. So that's going to be 2. F of 1 is the y value when x equals 1. Well, that's just 1. Arc tan of 1, now that's a trickier one. Arc tan of 1, you're asking yourself the question, tangent of what angle is equal to 1? Maybe you know that it's pi over 4. I would hope that you would. Arctan of 1 is pi over 4. This guy here is a perfectly acceptable final answer with no substitution needed. If you're like, whoa, where did pi over 4 come from? I'm not going to get into all of that right now, but what I want you to know is that arctan of 1 is some constant. And since it is some constant, you don't actually have to evaluate this. You don't have to say arctan of 1 is pi over 4. You could have just left your answer as 10 minus 3 times 2 over 1 minus arctan of 1, and you would have earned the same point as this kid who went and did all the evaluation. So leave it like this, leave it like this. This problem is only worth 1 point. For those of you that might have been thinking, but wait, I want to do L'Hopital. L'Hopital's rule does not apply here because you don't have a limit of the form 0 over 0. It's not an indeterminate form. So this is direct substitution. Get in, get out, and be happy with it. Congratulations.